All right, so what do we do when we have variables? We're actually going to start with the idea of using numbers. So let's start with the square root of 16. Well, can't we think about 16 as 4 squared? But what do we also know the square root of 16 is? Well, that's 4. So over here I'm going to write the square root of 4 squared equals 4. Interesting. Let's think about another one. Square root of 49. That's equal to 7. We could also think about 49 as 7 squared. So what's the square root of 7 squared? It's 7. Hopefully with these two examples, you can see, or at least trust me, that the square root of x squared is x. But what happens when we have x to the third? If we think about what we were doing with the numbers, we can break down x to the third into a perfect square part. X to the third, if we remember our exponent rules, can be split up into x squared times x to the first. And just like we were doing with numbers, we can break this up into two square roots. And what's the square root of x squared? Well, that's x. And the square root of x is like those numbers that we did beforehand, like 5, like 11. We can't simplify it anymore. So the square root of x to the third equals x times the square root of x. Now when we look at x to the fourth, we can think about x to the fourth as x squared times x squared, which is the square root of x squared times the square root of x squared, and the square root of each of these is x. So what's x times x? Exponent rule says x squared. So x to the fourth equals x squared. The square root of x to the fourth is x squared. Now we got one more. X to the fifth, we can think about that is x to the fourth times x. And we just did the square root of x to the fourth, which we said was x squared. And we can't do anything with that square root of x. It's not simplifiable. So look at these all together. Square root of x squared is x. Square root of x to the third is x times the square root of x. Square root of x to the fourth is x squared. Square root of x to the fifth is x squared times square root of x. You might be noticing a pattern. In this table, in the middle of the page, it explains what's going on. If the variable has an even exponent, it's a perfect square. We can divide by 2, and that will give us this square-rooted result. So the square root of b to the 46th power, well, if you're thinking 46 divided by 2, it's 23. Well, then we know the square root of b to the 46th is b to the 23rd. When there's an odd exponent, like x to the third and x to the fifth, we're going to need to subtract 1 from the exponent and leave one variable inside the radical. So n to the 35th, we can think about that as n, I was almost about to write an x, n to the 34th times n. And now the 34 is a even exponent, so we could divide that by 2. 34, oh, you can't even read that. 34 divided by 2, 17. So this is n to the 17th power times the square root of n. So anytime you have an odd exponent for a variable, you're going to have a square root of n, or square root of that variable left over, but you could take the rest out. If these make sense to you, you should try these 4. If you don't, you can follow along with me as I do them. But I think you should try, so you should pause the video, you should see what answers you would write down, check them versus what I get. So, h to the 10th, that's an even exponent, so we divide that by 2. Just dropped my pen. 10 divided by 2 is 5. So the square root of h to the 10th is h to the 5th. m to the 17th, that's odd. So we're going to think about it as m to the 16th times n. We're going to break it up into 2 pieces. one number smaller. 16 is even. We're going to divide that by 2. We get 8. So m to the 17th, when we square root it, it equals m to the 8th times the square root of m. Number 6, w to the 101st power. That's odd. So we got to break it up into w to the 100th times w. 100 divided by 2. It's 50. So we get w to the 50th power times the square root of w for that one. And 300. 300 is an even number, so we just get to divide it by 2. 150. So square root of a to the 300 is a to the 150th power. Now, the last page has a couple examples, and it's worth your time to do these because look at these numbers. They're quite big. I'm going to go as fast as I can here, write our list of perfect squares again, just so that you can see them on the screen as I think through them. Okay. So what's funny is that we start doing this and we start thinking that nothing's going to have nice answers. But if you can think about these perfect squares and you get comfortable and you notice them. Number 8, what's the square root of 225? It's 15. It's a perfect square. Don't forget that sometimes we can just take the square roots of numbers. Now 128, not on this list over here. So if you remember my hint from the first video, I'm going to think about like half. I'm going to start at the halfway point. So when I do 128 divided by 2, that's kind of like 130, and you cut 130 in half, that's like 65. So I'm going to start my division to see if any perfect squares exist at 64. So you either try it in your head or you go to your calculator and you do 128 divided by 64, and lucky for us, it's equal to 2. So we could take the square root of 128, rewrite it as 64 times 2, which is the square root of 64 times the square root of 2. And we did that because 64 is a perfect square. And what is the square root of 64? That is 8. Square root of 2? 2 is definitely not divisible by any of the numbers on our perfect square list besides 1, and we don't care about 1. So the square root of 128 is the same thing as 8 times the square root of 2. Number 10. Hopefully you tried it. Here's how I would do it. 192, if I cut that in half, that's what? That's got to be close to like 100, right? So maybe I'll start at 100. If I do 192 divided by 100, that's a decimal. If I do 192 divided by 81, you get a decimal. If you do 192 divided by 64 with your calculator, or again, if you're trying in your head, you will see that it is equal to 3. And that's what we're looking for, is a perfect square that divides that. So with the 192 part, we can rewrite it as 64 times 3. We also got this variable going on, so we got to do these two things at once. Lucky for us, though, that variable has an even exponent. So, folks, this 64 is a perfect square. This w to the 4th is a perfect square. So when we break the square root into 3 pieces this time, those 2 perfect square pieces, we can simplify. What's the square root of 64? That's 8. What's the square root of w to the 4th? That's w squared. And the square root of 3 we can't do anything with right now. Now, how are we supposed to write our answers? Because this is a little tricky. You always want to write the square root stuff at the back. So if you wrote, as I wrote, 8 square root of 3 and w squared, that's not technically the best way to write this stuff. You would want to rearrange it so that the square root stuff is at the back. 8 times w squared times the square root of 3 is the simplified version. All right, this last one, very large number, can be time consuming. Half of it's still like 600 something. So I'm gonna hope that starting at 225 is good enough and that I don't have to look for even bigger numbers to try. So if you do 1,183 divided by 225, you get a decimal. If you do 1,183 divided by 196, you get a decimal. If you do 1,183 divided by 169, that's where we get a nice answer, 7. So we can take 1,183 and rewrite it as 169 times 7. Because, why do we want to do that? 169 is a perfect square, and we can simplify that. Now we look at the variable. This time the exponent is odd, so we have to do a little bit of work. It stinks, but it's not the worst thing in the world. We can rewrite y to the 7th as y to the 6th times y, where y to the 6th is a perfect square because it's got an even exponent. So when we break this square root up into 4 pieces this time, square root of 169 times the square root of 7 times the square root of y to the 6th times the square root of y, we can simplify the 2 perfect square parts. And we're going to move those out to the front. What's the square root of 169 is 13. What's the square root of y to the 6th? Well, we divide the exponent by 2, we get y to the 3rd. So at the very front, we're going to write 13 y to the 3rd, and then the square root at the back. Now, remember, we can split square roots up, but we can go backwards and we can put them together. So the square root of 7 times the square root of y, we're actually going to write that as just 1 square root. Don't write it as 2. So our final answer for your notes today is 13y to the 3rd times the square root of 7y. I'm hoping that you're good starting your homework. Do your best over the weekend to do this. I know this can be tricky, but hopefully this made some sense for you. Have a good weekend.